Hello, and welcome to this lecture on map elements. We'll jump right into it. All right, so a map has three basic elements, which we will discuss in greater detail. Every map has three kind of common core things: the scale, projection, and symbolization. Importantly, each of these can be a source of distortion and or error, and so they need to be carefully explained to the user, to the viewer, in order for the viewer to understand these potential distortions or errors. All right, so scale, we'll start here. Essentially all maps are smaller than the reality that they represent, and scales tell us how much smaller that is. The scale relates the distance on the map to a specific distance on the ground. Okay, so predominantly scales are stated in three main ways. As text, like a short sentence, like 1 inch represents 24,000 inches. And you can see that kind of in the little image on the right as well. Or a ratio, 1 to 24,000. Importantly, when you're doing ratios, the units have to be the same, right? So it's no good if you have 1 inch representing 24,000 feet. That doesn't make any sense, right? And so in this case, we have 1 inch equal 24,000 inches, and 24,000 inches is actually the same as 2,000 feet. So these are actually related to each other, right? So 1 inch on the map is equal to 24,000 inches in the real world, okay? And the third kind of common way in which scale is stated is the graphic form. Okay, let's remember our ratios. 1 over 100 would be 0.01, whereas 1 to a million is 0.0000001, something like that, right? It's a small fraction. We have a big denominator. It is a small fraction. This makes it a small scale. 1 to 100, the 0.01, right? That is a larger scale, right? So translating that into distances in a map, right? This is a large scale map. It would be like 1 to 100, where 1 inch on the map is related to 100 inches in the real world, right? Whereas 1 to 1 million is that 1 inch on a map is related, it references or is related to 1 million inches in the real world, right? So that's a lot more area that you're packing into the 1 inch on the map. So small scale maps, like this 1 to 250,000 map from the USGS, is a relatively small scale map here. These areas are actually the main area here is in Charlotte. Then we can see kind of Concord and Thomasville, or not Thomasville, but Concord, and kind of stretching up 85 to Salisbury here, right? So 1 inch in the map relates to 250,000 inches in reality. A larger scale map is like this 1 to 24,000 scale map from the USGS. And here you can actually see individual buildings. You can see kind of individual roads, individual buildings. They may be dots on the map, but you can see a lot more detail, right, with this larger scale map, right? Generally, when we're depicting scale, you only need to show one type, right? And typically you show the graphic scale. You don't need to do graphic and text. And then we should think about the end use. Is this a map that's going to be printed out, as a trail map that people are going to take out in the field with them? Or is it going to be, some image on a screen? We might want to change how we depict the scale based on kind of its most common use. So let's kind of one last point here is to kind of hammer this in. Large scale maps have kind of a larger fraction, right? 1 to 100 or 1 to 16,000 in this case. They show a greater amount of detail in a relatively smaller area. There's a smaller extent. The map covers a smaller area, but it is able to show more detail. A small scale map might cover an entire continent or the world, but it shows a small amount of detail, right? So a small scale map, 1 to 190 million, right? We've got 1 inch on the map relates to 190 million inches on the planet, right? So you're really packing in a whole bunch of information into a small area on the map. Okay, so those are the differences, and this is important when we talk about large scale maps versus small scale maps. Important to remember this. Second common element here is projection. The world is not two-dimensional, maps are not three-dimensional, and so we need a way to kind of to go back and forth between these two things. And that is what a projection helps us do. A projection is needed to transform the curved three-dimensional surface of the Earth into a flat two-dimensional map. Okay, there are a lot of different ways to do this, a lot of different mathematical formulas of projecting the three-dimensional globe into these 2D maps. Lots of different projections. One of the most common ones, though, that we see, at least, or maybe in particular here in the US, is the Mercator projection. It is not an equal area projection. So you can see kind of this Mercator projection where Greenland is like, well, larger than Africa. And this is a valid projection in some cases, but it's not equal area. It doesn't actually represent the true size, the true area of these different places. And that gets exaggerated as you go toward the poles. And so you can see in this little GIF how the Mercator projection really distorts size. Okay, but Mercator projection is still a really valuable projection. And we'll talk about why that is in a whole nother class when we actually dive more deeply into projections. Okay, this will be a topic for kind of a whole nother day. But we need to know that projection is one of these one of the three common elements to maps. The third common element here are symbols, right? Symbols or symbology, these are the graphic symbols that make the features, places, and other information in the real world visible in the map. Okay, they can be really simple, like this little graphic of where UGA, the University of Georgia, is in relation to other parts, in relation to major roadways. Okay, really simple symbology here. We can almost pick it up kind of immediately. Symbology can be much more complex, like this weather chart, where they're condensing a whole lot of more information on this map, but you really almost need to be an expert to be able to read it, right? There's a lot of complex information distilled into a handful of couple symbols on the map, and it takes a lot more knowledge to be able to read and interpret these correctly. There are 6 principal visual variables when we talk about symbols and how we can symbolize real things real features in the real world to the map, right? There are 6 principal visual variables in terms of kind of how we can adjust or modify these things. One of them is size, so we can vary the size of points, lines, or areas. We can modify the shape, so that is often thought of with kind of these little icons or symbols. You can see, a little symbol for, say, like a factory or a school or a church or something like that, right? You can modify the gray tone value, so kind of like the intensity or saturation of the gray tone value, and you can use that to help you distinguish between, one area or the other, or one location or the other. You can use texture, you can use orientation, or you can use hue or color, red, green, blue, gray, blah, blah, blah. Okay, so these are the primary visual variables that you'll see. If you Googled principal visual variables, you might find another source that says 7 or 8 or 9 or something. But these are the kind of the primary ones that people talk about. And in some cases, these primary ones can be combined in a single map to help kind of represent information. Okay, and it's important to know when you as the map maker, you as the cartographer are creating the symbology for your map, it's important to do this kind of in a careful fashion, right? A bad match, poor match between the symbol that we choose and the data that it's representing can really confuse or frustrate the map user. And so if we just think back to like that previous lecture where we talked about proportional symbol maps, where it's natural that a larger dot, would represent, say, a city with a greater population than a smaller dot, right? So Charlotte would be represented on this type of map with a larger circle than Salisbury, right? It would be weird for us to reverse that, right? If you as a cartographer decided that a larger symbol would represent a smaller population size for a city, people would be really confused, right? So we need to be careful about how we do this. And another example of that is shown here, right? I suspect, although you can't read the legend of either this or this map, you probably have a pretty good idea of what they actually are, right? The top one is going from warm colors to cool colors. So it actually relates to temperature, right? Think about if you actually chose to have cool colors represent hot temperatures, how confused people would be. Or the bottom one represents land cover, right? Imagine if you chose white to represent forest and blue to represent cities. People would be very confused, right? So oftentimes people do have kind of an association with color or other types of these symbols. And so we need to be cognizant to recognize those. Otherwise, we will confuse and frustrate our map users. Okay, so a map has three basic elements. All maps have these three basic elements: scales, projections, symbols. And they should be explained on each map. A scale typically is explained via graphic scale bar, but it could be those other choices as well, text or the ratio. Projection, we often will have text that indicate what the projection is that we've used for the map. And then in symbols, the symbols are often represented within a legend or a key. They're described so that the viewer can understand and relate what they are to something. Last note here is that maps have a number of other elements, including a title, including attribution, like the name, date, or source of the data. They often have north arrows, and oftentimes they'll have insert or reference maps to give you more context, give you more indication as to where you are. Okay, and two more slides here. One is related to kind of key geography terms and definitions. Scale, this is the relationship between the map and the real world distance. When we talk about scale, that's what we mean. When we talk about extent, the spatial extent of something is the spatial scope of the map. Like, is it the extent large, like a continent, or small, like a small little town? The key or the legend is the map element that describes what the symbols mean. And the grain size, the grain of the map, is related to basically the smallest feature that you can see. And so you might have coarse grain maps, or you might have fine grain maps where you can see a lot of detail. So these are some important terminology. Lastly, I'm not going to go into too much detail on latitude and longitude, and I'll refer you to other material if you're unclear on these things. But we should, of course, all know what latitude and longitude is and how to interpret that, right? Latitude is basically a parallel. As you go north or south from the equator, that's our those are lines of latitude. And the longitude are lines around the Earth that run from the North Pole to the South Pole. Here. Okay, these are lines of meridian, latitudes are lines of parallel, right? We can represent them in decimal degree, these locations as decimal degrees or degrees, minutes, seconds. We can represent them in different ways, but we all need to know and understand a little bit about how to read and understand latitudes and longitudes. I like to think of latitude as like a ladder, you're climbing up or down, and longitude is going side to side.